Hello everyone, March 27th. Alright, it's a lot of coding today. For the past 2 days, actually. So we have dev stop today. Actually, yesterday on the 26th. And I need to complete a whole story from scratch. Honestly, not really from scratch because I did some research beforehand. So it was not completely from scratch, but almost. I would say 90% from scratch. 2 days to finish the story. Man, that was some insane coding. Just React, so nothing too bad. But the first time kind of actually feel you're coding, and I was on Vim the whole time. Man, I still like to use the mouse, like to use the trackpad. It moves around a bit faster than just using them. And the thing is, I like to just take a look around the code base, and if you use the page up and page down, it just doesn't feel it doesn't flow as well as using the trackpad, you know. And sometimes I even still using the mouse. Yeah, and I need to form the habit. Need to form the habit. All right, let's do today. Subarray product less than k. Given an array of integers and integer k, return the number of contiguous subarrays where subarray is contiguous to start with, where the product of all the elements in this subarray is strictly less than k. 8 subarrays. All right, so most likely is a DP. So we're gonna try DP on this. So we can say DPI is the total count of subarrays, let's say ending at I, and whose product is small, strictly less than k. Okay, so let's say we do that. Okay, so now we know DPI. Now we need to check the next one, right? So I need to check DPI. I need to know ending at I, right? So we need to check for DPI minus 1, which is ending at the one previous. I know how many is smaller, but that doesn't help me with DPI, right? Because what we want is what I want to know, right, is ending at I minus 1. Right? How many is actually smaller than k divided by this? Right? That's what I want to know. That is what I want to know. You know what? Maybe there is a better way, which is 2 pointers. How about 2 pointers? Like a sliding window thing. Right, we have I and j starting from here. So I starting from here. So we check 10 is good. This is good. Right, this is bad. So now I move this forward. So now I is here. Now we have 5 and 2. But if we try this, so okay, so we have a range. Okay, so we say everybody, like everything multiplied together is smaller than this. So any consecutive inside will be good, right? Anything inside will be good. So that will be all subarrays. That would be all the subarrays starting from I, right? So all the subarrays starting from I get it. Okay, so in this case, actually just these two, because this one fails, right? This one fails. So now I move forward. Okay, let's just say here, right? And then it fails here, so I have 10 and 10, 5. I have these two. Now we say, okay, I'll move I forward, so I now pointing to 5, right? Then I can keep moving, so I have this, right? So everything starts from 5, right? Everything starts from 5. Actually, this one's gonna go out, so everything starts from 5 is good, right? And then we move this one forward, and everything starts from 2, and everything. So yeah, everything starts from 10. Yeah, so start from 10. So 0, 1, 2. So it could be this minus, so it'll be 2, right? And then we move forward, and then we divide, so it'll be 10. So I can keep moving and keep moving. So this is 1, 2, 3, 4. So it'll be 4 minus 1, so it'll be 3. And then we go forward. So that'd be 4 minus 2 will be 2. And 4 minus 2 will be 1. So in total, we have these much, which is 8. Yep, I think that's the solution. 2 pointers. Yeah, I'm very confident on this one. And I'm only gonna do one today because it's late, and I just don't want to do more. Oh, I kept forgetting. All right, 2 pointers. So one of them will keep moving forward, right? So I can say for int I is 0, I smaller than nums dot length, I plus plus. Doesn't really matter. All right, and then int j is equal to 0. Okay, and int rest equal to 0, and int current equal to 1. Right. So we say j is equal to actually no, we should say while current is smaller than k, right? Current is smaller than k. K can be 0, right? Okay. Current is smaller than k, and j is smaller than nums dot length. Okay. Then we say a current times equal to nums j, right? Then we do the second one. Then we do the second one until we get out. So when we get out, doesn't matter if it's bad or not. So rest always plus equal to j minus I. Okay, and then we'll go on. I will move forward, right? I will move forward, right? I moves forward, and then when I moves forward, the current need to remove the current I, right? Current need to remove the current I. Oof. Okay, so it's a current divide equal to nums I. So we should start with nums 0, right? So start at nums 0. So first we divide. Basically, we'll divide by it, right? And then, because j is also here, so we'll get a j, okay? And then, oh, j need to plus plus. I have to do this, so plus plus. And then we try again, and then we'll plus plus until it's something with bad, and then we go on. I move forward. And when I move forward, current divided by the current I, right? Divided by the I. And then we're gonna add again, and get out. So every time I move forward, current will be divided by it. And then when we're done, we are going to turn the result. All right, let's take a look. Do we have a good one here? 9 and minus 3. Okay, that is pretty bonkers. Okay, so a couple things. I move forward. J shall equal to math.maximum J or I. So probably we'll solve one of the bugs here. Yeah. So now the other thing, I got 9. That's interesting because from the previous computation, it's not. Right, J plus plus and then J minus I. Okay, so we start from here. Current is 1. Okay, J is equal to 0. And then the first one's good. Current times nums J, so current is 10. J move here. And then current times this, now it's 50. It's good, so I move here, J move here. And now current times, now become 100. Ooh wee. So when we get out, we need to minus J. Because J plus plus, right? So we current what times 2 become 100. And J is already pointing to the next one. So we need to do that. That is stupid. That doesn't sound right at all. Hold on. So J, is it pointing to 2? I think J is pointing to 2, right? And then current times equal to 2. Right, because after 50, which is fine. And then current times equal to, current become 100. And then J is actually pointing here, right? And 100 is bad. We get out. So J, I say minus minus. Right, J minus minus. And then, maybe. Maybe the confusion happens because of this. Let's say, put J at 1. Okay, I is going to start from 0. Okay, I is going to start from 0. And then current is that. Okay, then J is good. Because I want I to be 0, right? I to be 0. So I is 0 and j is 0. So I multiply this. Yeah. I think this is good. We're just going to change this. Okay. Current times equal to nums j, right? If current is larger or equal to k, that would just break. Right, else don't break j++. Right, and now we try the next one. If it's larger, then we get out. So we're doing that. J always pointing to the right. J will point to the right place. And each time when I get in, we'll remove the previous, right? And then we'll start adding. Is this one right? So we start with 10. So current is 10. 10 divided, so current is 1. J is 0. So J start from 0. So current, what times equal to? So it will be 0. Okay, J++. Now it'll be 50. J++. Now it'll be 100. So we break. So J is pointing to here. So J minus 0, so we have 3. Okay. But J is pointing here, and I go to the next one. Right, I go to the next one. I think, no, I go to the next one. Okay, I go to here. Oh, I see the problem. Yep. This one just shouldn't happen here. Yeah, we start the one. Yeah, I see the issue. Which should happen here. Before you go to the next one, you remove the current one. Yeah, that is the key. Okay. So I thought this one would work. So basically it's 100, right? So it divided by 10. So we have 10, right? We have 10. So J should be 2. Then we have a 10. Now we have 60, right? Which is good. J++. Not really. J right now is pointing to 2, but I already did 2. Ooh, so I already did 2. So we're duplicating. So what are you saying? What I'm saying is, yeah, J++. So I'm J is current at 2, right? J is current at 2. And then when I move forward, because current at times equal to 2 again, we should not time. So basically J need to point into a thing. Okay. So instead of doing this, I should say if current times nums J. Alright, so we don't time it yet. If it's larger than, then we get out. Okay. Else current times equal to nums J plus plus. Right? Now that makes more sense. So we check it first, right? We check it first. If it's bad, then we get out. So J pointing to this, but we haven't used it yet. So we handle it. Then we remove the front. Now we get back up. So this is actually current is 50, right? Current is 50. So now it'll be 5. 5 goes in, then this is good, right? So we go on. 6, and then we'll go on, get out. I think this, come on, this gotta be right. And other scenarios, basically this just already guaranteed that if it's too big, then we'll do this, and then yeah, I think it's good, right? I think it's good. Take a little bit too long to solve this, but it's all right. It's all right. Two pointers with a sliding window. All right, we can throw some, I don't know, 10 or right, like that. Just throw some around and see if it handles. Nope, it does not handle. Wow, dude, that was bad. All right, let's see how. Ten gets skipped, right? So 5. So J is here, so that should be 1. And then move forward. So 5, 2, 6. What's my answer? Lordy. Okay, let's analyze this. So J star is 0. Current is 1 times this is 10, larger equal to K, so we break. So this is rest plus equals 0. And current minus equal to, ooh, shoot. Yeah, so it should be if J is larger than I, then we can do this. If J is not larger than I, then we cannot. We cannot remove. All right, now I'm gonna go. Yep. I have to go through a few test cases to make this right. Let's take a look. Is this 2-pointer accumulate binary such? Master log n. Oh, master log n. What is this method? Math.log. Jesus. What is this math.logn stuff? I have definitely more than one solution in the past. Prefix x in nums plus math.log x. K is log. So we take log for everything. Oh, we take log for everything, then we turn this into a plus. Okay. And then, I see. Then when we use prefix sum, but it is a log. Yeah, we just log plus, Then we go through the prefix for each one. We're going to bisect the prefix x plus k minus 10 to the 9th. What the hell is that? Wait, why do you minus 10 to the minus 9? Oh, I think this is for bisect purpose. This is for bisect purpose. Nah, now why do you do it this way? Yeah, I think we can probably improve this. Oh, equal. That's why. Equal. It'll be hard to find the equal sign. Let's check the solution. Sliding window. Oh, I got it. I was copy and paste this thing. That's exactly the same. Copy and paste is the exact same thing. Yeah, use this to handle the bias. And then I also have this. Actually, I don't remember. What's the third one? It's starting from I. So we're looking for from I plus 1 towards the end. I think that's what it means. And we do it slightly smaller. Right? Slightly smaller. So if we do it slightly smaller, then we'll hit that. Oh. So log num plus log k. So basically this minus this need to be smaller, right? This minus this needs to be smaller. So we want something slightly smaller. Yes, it makes sense. Yes. Yes, and then we can find the index and then index minus, basically minus I plus 1, right? Minus I plus minus I. Yeah, because we end up at a value that's slightly bigger. So this should be this one minus I, because it's starting from this, right? And then we have a logarithm of this. So basically this minus I minus 1. I think this minus 1, I'm not quite understanding why we need to minus 1. Because J, we bisect, right? We bisect, we binary search, basically 4. It's a log num plus log k minus this. So it's something slightly smaller, right? Something slightly smaller. So we'll bisect search this. So now we get what it is. And the index will be for the next one, right? It's basically for something slightly too big, right? Because this minus log m is going to be larger or equal to log k. So this one doesn't work, right? It has to be j minus 1. Yeah, that makes sense. It's actually j minus 1 minus I. That makes sense. J minus 1 minus I. Actually, hold on. That still doesn't make sense. J minus 1, right? So basically we say let's start. Hold on. I plus 1. Doesn't start. It does not start at I, does it? Yeah. It doesn't because it has a 0 at the beginning. It has a 0 at the beginning. So that makes sense. Yeah, that makes sense. But the sliding window is supposed to be this. You keep it first, right? You need to keep expanding first. I did it completely differently. You'll expand it first until you cannot. Right? You expand and you check. If it's larger equal to k, then you remove the left, remove the left until it's smaller than k, and then you do the difference between the two. Yeah, that's the right way to do it. Okay, so for yeah, that was there is a right way to do sliding window. Solution 1 is not the right way. This is the right way. So I can have all these, which is fine, right? And someone is moving forward, right? So now we are saying it's going to be J move forward. Actually, I'm going to put this as I. Right, so J is moved forward now. Okay, J is moved forward. And then each time current plus equal to nums, not plus equal to multiply, right? And I say while current is large equal to k, current divided equal to nums I plus plus. And now when it's done, right? Now when it's done, actually I don't even need this, right? So now when it's done, it's guaranteed that current is within k. So I can just say rest plus equal to j minus I plus 1. Yeah, there are right ways and wrong ways to do this. I tend to remember that sliding windows you always extend first. You'll extend first and then you... Oh, that's why they will... I think this is a special case. Ooh, what the hell? So basically, what happened? It's largely equal to, so this needs to divide it by the current value, then plus plus, so it cannot go beyond j. So it should be like this. Well, this and I is smaller or equal to j. How about this? I is smaller or equal to j. So we cannot keep moving I forward. So maybe I don't even need this condition. I can just rely on I smaller or equal to j. Yep. That's actually I think better than the official solution. There we go. There's an official solution sliding window. They have this thing, right? But right now I don't have to. And it's darn fast. It's darn fast. Yeah, I just did the sliding window the wrong way. You need to extend first and then remove from the front. That's how you're supposed to do. All right, so that's that. We're done. Good question. Okay, we're still stuck in this one. And it says binary search, not binary search, it says DP. So which basically means, right? So what they're trying to say is we'll do DPI will equal to the total count, right? The total count of beauty from, I'll say from the start, right? From the start. The start will be, we won't take 0, so from 1, right, to I, right? That's what we do. So now the question is, how do I compute DP, let's say I plus 1? The thing is, there's no DPI plus 1, right? You don't just plus 1. You do I plus K, right? All the way to here. Because you already can find what it is. So you do that. But how many is that? right? How many is the up into the next one? So that's the thing. I don't know. Or I mean, I was thinking about something easy. Like let's say 7. Okay. 7 we have 14, 28, 35, 42, 49, 56, 63, 60, no 70, 77, 84, 91, 98. Yeah. Oh, I'm trying to solve problems. It's always something interesting to do to keep your mind fresh. So we just read through this and then try to write a program to solve it. Like some people like to do puzzles. Some people like to play with locks. Some people like to play with Rubik cubes, and I like to solve these problems. And it doesn't always work, like this one, I got stuck, couldn't figure out how to solve it. But it's interesting, you just, if you don't know how to do it, you read other people's solutions and then you learn some new tricks and new techniques. Plus, it's always fun. Like this problem is fun. I would say it's fun. Is it useful? No, but it's definitely a good IQ test. Yeah. So, yeah. Say we have all these, right, and then we know that the good ones. Right, this is good. This is bad. Right. This is bad because we have to have an equal number of even and odd. So this is bad. This is a good. Good. This is a good. Good. This is a bad. 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 And a good. So if I know, let's say 14 is good, and I want to know, like I know f, right, because it's the way we define it, f14. So from a start to 14, f14 is equal to 1. F28 is also 1, right? F35 is 1. I mean, it's understandable because F14 is 1, and the next one is, dude, I think you forgot 21. Damn it. F21. All right, so F14 is 1, F21, and I can look at the previous one. So F21 is going to be 2, right? And then for the next one, this is bad, so it's going to be 2. And this is bad, so it's going to be 2. Okay, so yeah, we can definitely do it this way. And then we go all the way up. Like you can do F42 is also 2, F49. So yes, if I know Fi, I want to calculate Fi. If I know Fi minus K, right? If I know Fi minus K, and I know how many there are, then to know Fi, I just need to know if I itself is, and then, well, of course, we always start from divisible. So just if this is a beautiful number, if it is, then it should be plus 1. If not, then we don't. But the problem with this is if our k is small, because k can be 1. If k is small, then we have to go through every single one of them. Okay, every single one of them, and a high bound can go all the way to 10 to the 9th. That is what is bad. AI machine learning models, not with the fancy ones nowadays. those large language models, no. I did do the most statistics-based version. Basically, most of the stuff in scikit-learn, I did a lot of work in that. I did a lot of work using scikit-learn. Basically, my dissertation is scikit-learn. You know, the traditional data processing stuff, your PCAs, your I did some Gaussian processing, and what else did I do? Mainly PCA is the main thing, right? I did all types of PCAs and MLPs, but those are all statistics based, right? It's very straightforward, not the deep learning stuff. Yeah, that's the word, deep learning stuff. No, didn't do much deep learning stuff. Touched upon it, PyTorch. Did I use PyTorch? I don't think I used PyTorch. I think I used the other one. Damn, I forgot the name of the other one. I don't remember. I did some reinforcement learning as well. That was fun, but didn't dig too deep into it. Things is changing too fast, the machine learning side. Yeah, the gradient booster tree did use that, but for my data set, when I was working on it, it was not the best model for me. So, I did the k nearest neighbors. That was the one. That was the one method that works very well for, I shouldn't say very well, but decently well for my data set. So a lot of k nearest neighbors. Well, good luck with that. Voice to voice. So what, you ask a question and then it'll tell you stuff? Like what your vulnerabilities are? Definitely a good thing. I mean, I think a lot of people trying to do something with this because cybersecurity is a big area that probably haven't been fully penetrated by machine learning yet. But large language model definitely can play a role there. All the CVEs, CWEs, there's a ton of stuff there, and then the data is definitely not structured. So I did do some work on that, and it was a whole pile of stuff, very um, very natural language like. So it will be, yeah. I think the problem that we tried to solve before was try to build a graph. Like if you know a CWE, or if you know a CVE, can you trace back to its CWE, to its CAPEC, to everything that's related to it, right? So if you know, you will get a lot of report of your CVEs. So from these CVE and its description, can you get everything on the whole chain, starting from what's your vulnerabilities, what's your exposure, like all of that. But that's like a graph, right? You need to build a graph, and probably you need LLM to build this graph. And once you can build this graph, I mean the rest is not that hard, right? I mean the rest is just sugar, right? The base one, right? The base one is how do you query this thing, right? How do you make sense of all the CVE, CWE data out there? I mean, the human machine interface nowadays is just so powerful. Voice recognition is very good. You can probably just use some APIs from Google, right? Uh, language, the chatbot stuff is also quite straightforward nowadays. Yeah, so the difficult part is always the underlying. How do you make sense of the data, right? And cybersecurity wise, you have tons of unstructured data. You need to make sense of that. See, that is the that if you can figure that out, right? If you can query, yeah, it's like it's the cybersecurity data is not in a well-defined relational database, right? So you need to structure that and find a way to query it. And if you can do that, if you can find a way to put into a graph, okay, make it queryable, yeah, that will be a good project. Then you can probably sell it for a lot of money, because there's too much data in cybersecurity, but too few understanding and comprehension of what those things are mean. I mean, every day you can get, I don't know, thousands of CVEs on your system. You're like, what does that mean? What does a CVE mean, right? Does that mean I have exposure where? Or if I know, how do I address it? The data's out. The data is there, right? The data is there. It's hard to make sense. It's hard to make sense of all those things. Yeah, good luck with that. It's a very difficult thing to do. Very difficult thing to do. Because just the data itself doesn't make too much sense. It's all natural language. So you need to build connections from one piece of natural language to the other, right? I mean, in the CVE database that's provided, I mean, supposedly each CVE will be mapping to one CWE, right? Supposedly that's how it should be. But in reality, it's not, right? Some CVEs have no mappings, and some CVEs has, I mean, these mappings are done by humans, so it's not exhaustive, because there will be some CVEs that have correct mapping, but not to all of them, right? There will be some CVEs has incorrect mapping, and then this, if you cannot do this type of mapping, it will be very hard to build a product. Yeah, I mean, my this is as far as my knowledge extends, because my previous project, a minor one, is has something to do with this. It's trying to see if we can build a mapping between all these things. But then, yeah, it's too hard for me. I lost interest in all this. All right, like back to this. I mean, again, if I know, yeah, you can't just do it this way. I mean, 2 digits, it's okay, right? 2 digits, I mean, 2 digits I can always do. And because it has to be even number of even and the same number of even and odd digits. Therefore, the next you need to, so these are all the 2 digits, right? So next we need to do is 4 digits, right? Now we need a 4 digit. 4 digits. What's the first 4 digits that's divisible by 7? Interesting concept. No, I don't have Discord. I don't have much. I don't do social media stuff. I'm pretty anti this whole thing. Dude, it's 1001. Okay, so my previous idea is, can we construct now these numbers from the ones we know? And apparently we can, I'm gonna say cannot. Because how do you construct so what's 1001? Well, 1001 is 143 times 7, right? And this basically is 2, 3, 4, all the way down to, this is 10, 11, 12, 13, 14, right? Yeah, I don't see how we can do this, honestly. $1,001. and then would be 1008. That doesn't make any sense because it simply doesn't work that way. It does not work that way. Huh. Yep, I have still no idea. Still no clue. Yeah, basically, we're trying to say if you do F1001, what's the answer? Right? Man, you can say if I do this, then I basically I can do F98, right? Because everything in the middle will be skipped. Okay. Then you need to know F98. 2 digits I can compute. But what if I give you something more? Let's say 555 times 7, right? Just give you that 3885. 3885 is also good. Like how do you approach this? You can't just keep going because it's just not possible. I mean, we can. You want to try? We can actually say from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It will give you an answer in short time. Right? It gives you an answer. So yeah, that's. I gotta think about this again. Okay, I'm very close to give up on this because really I have no clue. I have absolutely no clue. The hints are not really helpful. I mean, it does point into a direction, but how? What's the transition? It's a DP, right? But what's the transition from one to the other? And what if your value n is huge, right? Your n is huge. I wonder if there is a formula for this. All right, anyway, I'll end it today. So it's been an hour. I'll give it more thought tonight. If it still doesn't work, yeah, I'm going to check the discussion. I'm going to check the answer. Stuck. All right, that will be it for today. I'll see you guys tomorrow. Adios. Oh, and good luck. Good luck to your endeavor into this project. If you can do it, I think you can save. You can save. Not save. You can make some money out of it. No, I don't know. I don't know if there's any equation for this. I'm just guessing.